Hey CS mate, what's big O notation? It's pretty simple, so don't worry. Pretty much when designing algorithms, we want to consider the efficiency of an algorithm in both space and time. So, here we go. At lower input sizes, and if we say n is our input, the time and the space complexity doesn't really matter all that much. But as we increase the input size to say millions, then we have to be more concerned about how well it runs. So, plus as software engineers, we want to prioritize efficiency just as a general rule. But the lower time complexity we have and the lower space complexity we have, the more efficient the program is going to run. So, how do we represent this then? Well, big O notation is how we describe the worst case runtime of the algorithm. In other words, how it behaves when n approaches infinity. Kind of like limits if you've taken calculus. So there's a couple general functions that we use to describe the worst case runtime. We have O of 1, we have O of log n, we have O of n, we have O of n log n, O of n squared, and O to the 2, O of 2n. So exponential time pretty much. As you can see, these are just like general pictures so you get an idea. It's pretty interesting how at lower input sizes, kind of like how we talked about earlier, it doesn't really matter all that much. They, some perform better than even O of 1 at low input sizes. However, we're taking it to infinity. If we're designing like an app or something like that that has millions of concurrent users, then we're going to be getting pretty close to millions of people. I mean, if it's popular. But I guess if your app isn't that popular, then time complexity doesn't matter all that much. But essentially, what I'm trying to say is, you want to design algorithms with as best time complexity as possible. So needless for loops when you're to iterate through all of your data. That's gonna hike up your time complexity. Typically you want to go for O of log n, but these other ones you want to kind of try and avoid. O of 1 is like great, but that might be like omega n, which is best case runtime. But we can talk about that in another video. But some examples of things that run in O of log n are like binary search trees. So, if we have 5, then we have 2, then we have 6. Well, if we're looking for a number, the binary search tree, it just compares in its searches, compares the whatever you're looking for, say that's X, to the current node. And if it's less than that, it goes to the left subtree. If it's bigger than that, it goes to the right subtree. So each time you're cutting off half of the tree. So that's why the search runs in O of log n. An example of something that runs in O of n would be like a linked list, where you have to look through to find a specific node, you'd have to look through every single node to find that one until you get there. So, it might be like a for loop while, temp doesn't equal null pointer. And this is C++, by the way. It's just easier for like illustrating memory management ideas. But, and then you might have something in here that says if temp data equals, 5, then, return temp, right? And then else you just do temp equals temp next. So my point, though, in all this is, look, you have to keep going through every single one of these linked list nodes to get all the way until you find 5. So worst case scenario, you might go through the entire list. So as we're talking about worst case scenario, if there's n nodes in your linked list, and you have to go through all the nodes, worst case is O of n. Anyway, though, so all this is just kind of the start of asymptotic analysis, which I can talk about in a different video. But hopefully this was helpful and just kind of getting a groundwork understanding of, big O notation. Let me know if you have any questions. Hopefully this was helpful to you.